Good afternoon. Today we are working on PO4. I can find the greatest common factor of a set of numbers. Who remembers what a factor is? What is a factor? Some of us kind of remember. I see some hands half going up. I know that name. What was it again? What do you think the definition would be, Lucas?
One of the numbers that is not the answer in a multiplication problem.
I'm sorry, say that again?
One of the numbers that is being multiplied in a multiplication problem.
Okay. So you are correct, but I'm going to explain it in a different way that might make a little more sense. Okay. So a factor is a number that goes evenly into the given number. So it goes evenly into it. So you could have 1.5 times 2 equals 3, but we wouldn't say that 1.5 is a factor of 3. So that's why I'm clarifying the way you were explaining it. It has to go evenly into it. It has to be a whole number to be that factor, right? It goes evenly into it. So it wouldn't be 1.5 as a factor of 3. What would the factors of 3 be? What numbers go evenly into 3 when we multiply? Does it? 1 and 3. So even though we know 1.5 times 2 equals 3, that can't be the factors because 1.5 doesn't evenly go into it. It's a fraction. We don't want those fractions. So if we have examples, let's say we want the factors of 12. Think about your multiplication facts. Think about what numbers we multiply together to get 12 that evenly go into 12. No fractions, no decimals. Will?
4 times 3.
3 and 4. So 4 times 3, 3 times 4, they're factors of 12. Damien?
6 times 6.
2 and 6. Blakely?
1 and 12.
1 and 12. I put them in order when I write them, even though I don't always think of them in order. But I put them in order for a very good reason. We're going to see why. So sometimes we get those factor buddies, 3 times 4, 2 times 6, 1 times 12. When we get factor buddies together, it's easy to write it that way. 3 times 4, 6 times 2, 12 times 1. We always, when we're looking for greatest common factors, we're going to want to take those factor buddies and put them in order from least to greatest. Okay.
Isn't this on Khan? I believe it was.
Yeah. Because I knew it was coming up this week. So Khan Academy, if we've already been working on it, we already got exposed to what we're doing today, and it's going to go easier because I knew this was coming up this week. So there are different ways to find the greatest common factor, the GCF, the greatest common factor. So finding the greatest common factor is as easy as 1, 2, 3, or FCG. So let's see what FCG means. The F would be list all factor pairs. So that's our F. List all factor pairs, those factor buddies, of each given number. So up top, I only gave us the number of 12. But if we're wanting to find the greatest common factor, we're going to have more than one number that we're looking at the factors with. So you want to list all those factor buddies all the factor pairs of each number you're given. Then we have the C. Circle the common, that's our C, common factors. And the G is identify the greatest common factor. So a common factor are the ones that are in both numbers. So if we were to say factors of 12 are 1, 2, 3, 4, 6, and 12, what about factors of 15? What are my factors of 15? Lately? 1 and 15. What else is a factor of 15? Gabe? 3 and 5. So I listed all of my factors of 12. I listed all of my factors of 15. I have to circle common factors. And then I have to identify the greatest common factor. That would be 3. So the greatest common factor between 12 and 15 would be 3. Because I listed all of their factors. I put them in order so I can see which one is the greatest. And I circle all common factors, and it's the greatest factor that they share. Then we have a second method. So are we good with up above? Can I erase?
No.
So we had listing all of our factor pairs, all those factor buddies. I call them factor buddies because they go together. Factor pairs is the more mathy way of saying it. You list them all. You circle the common, 1s and 3s they had in common, and then we find the greatest one, the biggest common factors that they share is our greatest common factor. So now, the greatest common factor of each method to the table method, it says it's shown below. They did not show it below. Interesting, Mr. Schultz. I'm not sure. He changed up, whoops, it's not scrolling. He changed it up from my answer key that I have. So if we look at our greatest common factor over on my board over here, I'm going to move these up front, so I have them up front. So I can show you how to do the table method, and we're going to show it on our paper. So, greatest common factor for 36 and 120, I'm going to show you how to do this. I guess I'm going to use this space right here. So I'm going to use 36 and 120. Okay, so if we have these two numbers and we want to find the greatest common factor, I have 36 and 120. I can take a 2 out of both of those. If I take a 2 out of 36, how many is left? What's its factor, buddy? Grace? Matthew? 18. What if I divided 2 out of 120? Grayson? 60. So now I had 2 times 18 is 36, 2 times 60 is 120. That is a factor that they share. So now I can divide another 2 out. What would I be left with, Claire? 9 and 30. Can I divide something else out of 9 and 30? Jude?
You could divide 3 out of it.
3. 9 divided by 3 is 3. 30 divided by 3 is 10.
Yeah.
So, here's how I use this to find what my greatest common factor is. I've gone down to all of my primes, and I can't take any more primes out. I can take out a 2, I can take out a 2, I can take out a 3. So now, to find my greatest common factor, I'm going to multiply those primes together. 2 times 2 times 3 equals 12. That is my greatest common factor. So I can see which primes I can divide out and keep getting smaller and smaller, dividing out primes. So always start with the 2, the 3, the 5. See what you can divide, which prime you can divide out. So let's see how that works for 40 and 72. It says use both methods. So the first method would be listing all of my factor buddies for 40 and listing them all for 72. What are my factors of 40? Will? 1 and 40. Madden?
4 and 10.
4 and 10. Emerson?
2 and 20.
2 and 20. Do you have anything in the middle there? Oh, we have
5 and 8.
5 and 8. I think that's it. I'm not sure what's happening at the back table, but it's loud and it's distracting. Please stop. Okay. Now my factors is 72. Grace? 1 and 72. Claire? 2 and 36. Christian?
12.
And
12.
6. Oops. 6 and 12. What else do we have? Grayson?
3 and 4.
3 can go into it.
Oh.
Will?
9 and 8.
9 and 8. What is 3's factor, buddy? So if we have 72 divided by 3, 3 goes into 7 2 times. Lauren? 24. What's another one, Madden?
4 and 18.
4 and 18. Oh my goodness, look at all of these factor buddies that we have. Now, we need to find all of their common factors. So they share 1, they share 2, they share 4, they share an 8, they don't share 10, they don't share 20, they don't share 40. So what is the greatest common factor here? Christian? 8. Why might this be a hard one to use? Claire G?
Because it takes a lot of time to list all of them. It takes a lot of brain time.
It does take a lot of brain power when we have a big number like 72 with lots of factors. What can easily happen when we're listing factors for a number like 72? What could easily happen, Claire?
Mess up so you might not get all the numbers.
Yeah, we might miss some factor buddies. What if we forgot about 8 and 9? We would have thought our greatest common factor was 4. It's easy to miss factor buddies. So if you are going to do the factor buddy method where you're listing off all of the factors, you have to go really slow and make sure you get every factor. The way I do it is I start with 1, because I know 1 is a factor for every number, 1 in the number. Then I think, does 2 go into it? Does 3 go into it? Does 4 go into it? Does 5 go into it? And I work my way up until I get to the flip side. Oh, I've already put 8. I already had 5 and 8. So I'm done finding factors because I've already hit that factor buddy on the other side. But sometimes we have a big, long list we have to make. That's why we teach us the different way of doing factor buddies. Not factor buddies, doing the greatest common factor using the table method. So using the table method, we would start with 40 and 72. And then we want to take out a prime. What's the first prime I should check to take out? Jude?
You could do.
What's the smallest prime?
The smallest prime, 2.
2. So let's take out a 2. Because they're both even numbers, I can take a 2 out. What am I left with if I take the 2 out? What are the factor buddies? Jude?
20 and 36.
And if you're not sure, can you use a calculator to check? Sure.
Yeah.
So now I have 20 and 36. What's the smallest prime that I can take out of 20 and 36, Christian?
2.
I can take out a 2. So if I take out a 2, what am I left with? Fiona?
18 and 10.
18 and 10. What's the smallest prime I can take out of 10 and 18, Will?
2.
Another 2. What am I left with, Will?
5 and 9.
Is there a prime that I can take out of both 5 and 9? No, that's as small as I get. There is not a prime that I can take out of both 5 and 9. So what do I have to do now to find my greatest common factor? Will?
Multiply the numbers that you divide with.
I'm going to multiply all those primes together. 2 times 2 times 2. James?
8.
2 times 2 is 4. 4 times 2 is 8. Look at that. Same answer. Did I have to use all that brain power trying to find all the factors and worry about missing a factor buddy and then I don't get the right common factor, that greatest common factor? No. When I just take out those primes with the table and multiply the primes together, I'm not as worried about missing some factor buddies. So let's do our next one. 12, 30, and 60. So when we do it this way, we have 3 numbers. What's the smallest prime that I can divide out of all 3 of those numbers, Grace? 2. What am I left with, Grace?
6, 15, and 30.
6, 15, and 30. What's the smallest prime I can take out of 6, 15, and 30, Lauren? 3. What am I left with, Lauren? 6 divided by 3 is
2,
15 divided by 3,
5,
and 30 divided by 3. What is the smallest prime I can take out of 2, 5, and 10, Damien?
you can't.
I can't. That's where I stop. There's no more primes that I can divide out. So what do I have to do, Christian?
Multiply 3 times 2.
Yeah, I'm going to multiply those primes. What is 3 times 2? 2 times 3. Christian? 6. So let's see if we do our listing, if we get 6 when we list them all out. So I have 12, 30, and 60. What are my factor buddies of 12? I've got 1 and 12. I've got 2 and 6 3, and 4, not during the lesson. 30, I have 1 and 30, 2 and 15, 3 and 10, and that's it. 60, I have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 6 and 10. Now I need to go and find common factors. 1, 2, 3s. Oh, I forgot a factor. 5 and what? Is it 12?
Same with 30. You forget 5 and 6. 5 and 6.
Oh, see? So easy to miss some of those factor buddies. So then they don't show 5, they share 6. So all 3 of the numbers have to share. The greatest one that they shared was 6. And you just saw how easy it is to miss a factor buddy. So either way, if we do it correctly, we get 6 as our greatest common factor. Super easy to miss some factor buddies. You can use that method, but you have to make sure you don't miss any. Or if I hadn't checked myself and went, wait, this isn't right, I would have stopped at 3 and said 3 was my greatest common factor. Oof. And then I would have gotten it wrong. So always make sure you have all of the factors listed. Henry?
It looks like the higher the number, like the more numbers you have.
It seems like the bigger the number you have, the more factors you have, unless if we have like 33. Seems like a big number, but there's only 4 factors, right? So it depends on, it just really depends. Sometimes there's more, sometimes there's not. So let's look at our work for today. Numbers are relatively prime. It sounds pretty cool if you say it with the British accent. I'm not good with the British accent. But if they're only, oh, this is important. If their only common factor is 1, they are not prime numbers themselves, but are prime when compared to each other. So 8 and 15 would be an example. 8 and 15 are not prime numbers, but the only factor they share is 1. So if we look at the factors of 8, we've got 1 and 8, 2 and 4. Factors of 15 are 1 and 15, 3 and 5. So when they only share 1 as their common factor, then we say they're relatively prime because they only share 1 as their common factor. They're not prime, they're relatively prime. So it's important to know that. So for our work today, find the greatest common factor of the set of numbers. You may use either method that you wish. It's possible that the numbers will be relatively prime. You must show your work. You can't just look at it, do the math in your head, and put down what the greatest common factor is. You have to show the method you used and show how you got the answer. So it is important that we, even though you might be able to figure it out in your head, show the work. Show which method you're doing. Dude?
Can you do the same method every single time?
Yes. If you really like the factor buddy method, use that every time. If you really like the table method, use that every time. It's fine. Or you might say, hey, these are smaller numbers, I can do the factor buddies. They're bigger numbers, I want to do the table. Please stop talking. Use which one works for you. Then we have word problems. So now we're going to use the exact same thing, but we're doing it as word problems. So so let's turn to this page. You are creating prize bags to give to guests at your birthday party. You have 18 kazoos, 45 fake tattoos, 36 stickers with famous mathematicians on them. What is the greatest number of identical prize bags you can make using all the items? What method are we going to use? Or how are we going to solve this word problem? We're looking for the greatest common factor. That's how many prize bags we're going to have. What the greatest common factor is, that would be our prize bags. And then to figure out how many fake tattoos are in each bag, find its factor buddy. So we could say 18, 45, and 36. I can can't pull a 2 out. I pull a 3 out and get 6, 15, and 12. I can pull a 3 out and get 2, 5, and 4. Oh, I can't pull anything more out. So I'm going to do 3 times 3. Oops. 3 times 3 equals 9. So there's going to be 9 bags. How many fake tattoos are going to be in each of those 9 bags? Jude?
Would it be 3? Or no?
I have 45 fake tattoos. I have 9 bags. Lauren? How did you get 5, Lauren? 45 divided by 9 is 5. So I know there's 5 tattoos. I don't even know how to spell tattoo right now. Oh, there we go. I know there's 5 tattoos in each bag because that's its factor buddy. So you're going to do that with each of these word problems. You're going to figure out they're all greatest common factors, but they might have 2 questions. So you might have to take it that step further. Here's the thing. Tomorrow, what are we doing in math class? Grace? We're math testing. So is this due tomorrow? No, because tomorrow's math class is doing the math test. This is due on Wednesday. So it is a 2-page homework, but it's due Wednesday. Go ahead and listen to announcements. For my friends at home, I hope you are well, and I hope to see you soon. Have a wonderful day.